In this video, we're going to discuss compositions of functions. And actually, we're really talking about two things. We're talking about compositions of functions, and we're talking about operations of functions. And when we're talking about operations of functions, we can be talking about one of four things. We can be talking about f plus g of x, which is where I take the f of x and add the g of x to it. I could be talking about f minus g of x, meaning that I take away g of x from f of x. I could be evaluating f times g of x, which means that I am multiplying the two functions together, or I could be dividing f over g of x, which is the same thing as saying f of x divided by g of x, as long as g of x does not equal 0. That's important because remember, you can't have a 0 in the bottom of a fraction. So we will be able to do all these things and evaluate the domains. And a lot of times it's just easiest if we start with an example. So we're going to have f of x equal x squared plus 2. And then we're going to have g of x equal the square root of x plus 1. And let's do a couple of operations. Let's add. Let's multiply. And let's divide. And we're going to evaluate the domains or determine the domain. So if I start with f plus g of x, I just have to take x squared plus 2 plus the square root of x plus 1. Now, the domain is kind of the challenging part because you have to think about the domain of this function, which is all x values greater than -1. And then you have to think about this domain, which is just negative infinity to infinity. And you're really just considering where these two domains overlap. Or you're thinking about the intersection. Because even though I can use negative infinity to infinity here, I can't use it here. So the only portion that actually works for my brand new equation, f plus g of x, has to be where the two domains intersect, which is just from -1, and that should be a square bracket, -1 to infinity. And that holds true for all of these, except for the division one, which we'll get to in a second. So if I have x plus 2 times the square root of x plus 1, you might be tempted to try to like multiply or distribute. And honestly, that's a little bit more trouble than it's worth. Because technically, you can't really multiply the x squared inside of the root. That's not allowed. But what you can do is kind of treat this as one individual term and say x squared multiplied by x plus the square root of x plus 1 plus 2 times the square root of x plus 1. That would really be the only way that I could say you could simplify that. The domain of this function, again, is still just going to be this. Square bracket, -1 to infinity. Because again, it doesn't matter that I'm multiplying x squared to the root. I still can only plug in at least the smallest possible number being -1. Similar process to the division. First I write it. And we're not worried about rationalizing denominators at this point because that's beyond the scope of what we're focusing on right now. But again, your domain technically, after we divide the two, because you can't simplify this, you can't do anything with this x and the x squared. You can only cancel things if whole factors cancel. So if we were applying the same process we did before, the domain of this function would be -1 to infinity. However, since we have a fraction, we always need to go back and look and make sure that because of the fact that I have introduced a fraction, that I haven't now limited my domain further. And if you think about the fact that if you plug in -1 right here, you get a 0, that's not very good. So all we have to do to adjust our domain a little bit is just switch that to a round bracket. Now let's talk about the composition of functions. And you may have seen this written a bunch of different ways. A lot of times you'll see them written, I fondly call them as fog and goff. So with fog, it's the same thing as saying f of g of x. The O is kind of saying of, if that helps you. A lot of times people mix up fog and goff with multiplication. So always make sure you're being careful whenever you're looking at that. So when you're looking here at these two functions, you're plugging an entire function g of x in for f of x. And this process, I think you did a lot last year. So I'm pretty sure it should be familiar to you, but the domain part is sometimes the challenging part. So let's evaluate. We'll stick with our same two functions. So f of x equals x squared 2, and g of x equals the square root of x plus 1. So the first one I'm going to do is fog, or f of g of x. So I take, for every single x, I am putting in this. So I have the square root of x plus 1 going in for this x here. And then the rest of it is staying the same. So that's going to become squared and then a plus 2. So conveniently, when I square the square root and the square root cancel each other out, and I have x plus 1 plus 2, which is x plus 3. And this would be f of g of x, which is pretty simple to evaluate. But now the domain is kind of the part where we have to think a little bit critically here. So basically, I am taking all of the x values in here and plugging them into, or my g of x is becoming my f of x, my f of x's x values, which means that if I was not allowed to use an x value in the beginning, I'm not allowed to use it here in my f of x when I plug it in. So even though this domain is all real numbers, it's actually not, because it came from these two original functions. So since my domain here was yet again -1 to infinity, those are the only x values that I'm allowed to use here. So even though this is all real numbers, and in turn this ends up being all real numbers, my domain of this new function is only going to be -1 to infinity. I can't use all real numbers because I initially wasn't allowed to use it in the very beginning. Now let's think about g of f of x. So this time I'm doing the opposite. I am taking f of x and putting it into x for g of x. So I have my square root of my original function. And in for x, I am putting f, which is x plus 2, the square root of x plus 2. And then I have this plus 1 from my original problem. This one's a little bit more straightforward because you will combine the two things. And just be careful because you cannot square root the x squared because this 3 is connected to it. And there is no way to factor this or somehow simplify it. So this is my g of f of x. Now to think about the domain again. Since I was plugging in f of x into g of x, my domain, I have to consider the domain of this function here. So this function was -∞ to infinity.
So that means that every single x value in the universe, I am allowed to plug in here. So if I continue on, I am still allowed to plug in every single x value here. I just need to be aware of the fact that since I now have a radical in my equation, when I didn't when I started with f of x, I might have to restrict my domain. So if I think about negative infinity to infinity, and I think about this equation, I want to think about where this graph is equal to 0, because usually that tells me some values. And since when I square root both sides, I end up with plus or minus the square root of -3, that means that I'm only restricted by imaginary numbers. So this domain is just going to be negative infinity to infinity. Because my domain for my f of x, which is what I plugged into g, was negative infinity to infinity. And then when I went through and did some simplifying, I ended up not having any values that made a 0 under the radical. So it stayed negative infinity to infinity. And that's all I have for you today. So go ahead and work on your assignment, post any questions into the Burning Questions discussions page, and we will talk about them later.